hello again. This is another production of Fuel, the Foundation for Equity and Excellence in Education in Liberia. We are going to be going over yet another section of the West African Examination Council's Senior Secondary School Mathematics Examination for Liberian schools. We're going to be going over a section on statistics. This is the second in the series of our 3 videos on statistics. And on this section here, on this section, we're going to be going over the measures of central tendencies and the measure of dispersions on group data. So basically, what are the measures of central tendency? We call them the measures of central tendency because they are used to approximate the center of the data, the center point. They are mean, median, and mode. What is the mean? The mean is another way of saying the average. The median is the middle data element when the data is arranged in order. And the mode is the data element which occurs the most. We can compute the mean by using some of these formulas we have here. We just kind of put both formulas for ungrouped data and group data. We're going to actually get into the problems, you're going to see how it works. That means you add up all of the data elements using the summation there and then divide it by the number of elements you have. So then there's a formula here for finding the median. We will not use this formula and let's not even worry about it. Then we talk about the measure of dispersion. The dispersion is an explanation of how spread the data is from each data. The data is spread. How vast the data is spread. So several measures of dispersion includes the deviation, that is the difference between an observed value or a data element and the mean, and the standard deviation, which will show you how we compute, is a measure of spread. And then we have the lower quartile. The lower quartile is basically the median of the lower half of the data, and the upper quartile is the median of the upper half of the data. Then we have the interquartile range. The interquartile range is the difference between the upper and the lower quartile. Another measure of dispersion is the range. For some reason, we did not include that here. The range is another measure of dispersion. So what's the range? It's basically the maximum, let me use that, minus the what? The minimum, that is the data with the largest data element minus the smallest data element. So that's the range. So these are all measure of dispersions. So here's a formula for calculating the standard deviation. It says we take the square root of the sum of the deviation. The deviation is when you take a data element and subtract the mean from it, and that's how we represent the mean. And then you square them so that you get all positive divided by the total number of elements you have. So we have problem number 1 here. It says if the mean of 15, x 18, and 3 is 19, find the median. So let's first of all write the formula. We say mean is equal to the sum of all of these values here divided by what? N. So let's see how we can connect this to our problem. So in this problem we have our mean, the mean of 15, x 18, and 13 is 19. So our x bar is 19. So we're going to incorporate that into our problem. X bar is 19. So now, then we need to find the summation of these elements. Can we find the actual sum of them? Well, not. But let's see. Let's go here. So, and then n is the number of data elements we have. How many do we have? 1, 2, 3, 4. So 4. So let's go and do this. So x bar is 19. I'll put that in it. My mean is 4. Let's add up my elements here. What are they? 15 plus x plus 18 plus 13. Now we don't know what x is, but that's fine because we can multiply 14 by 19 to get. So we multiply this by 4. We multiply this by 4. We eliminate the 4 here. 4 times 19 is 76. And then we're going to add up all of these over here we have. So we're going to add x plus 15 plus 18 plus 13. And when we add those numbers, 3 and 8 is 11 plus 5, that's 16. We're going to have 46. So I have 76 is equal to x plus what? 46 minus 46 minus 46. We're going to see that x will be equal to what? 30. And we can check that. You can plug 30 into that, add it up, and divide it by 4, and you're going to get what? 19. Okay? So now we got x to be 30, but that's not what we are looking for. In this problem, they wanted us to find a median. Well, to find a median, we needed to know what x is. We know x would be this. So let's list the numbers in the correct order. So the smallest is 15. Then we have what? Sorry, the smallest is what? 13, correct? So the smallest is 13. Then we have 15. Then we have 18. And then we have 30. So how do we find a median? The median number is the middle number, but we have an even number of numbers here, 1, 2, 3, 4. So there's not clearly a number in the middle. So how do we do it? We find the average of the middle. So if you have 4 data, then counting from each end, when you divide 4 by 2, you get 2. So counting from each end, the number in the second position will be you add them up. So you got 15, you find the average of 15 and 18. So we divide 15 by 18, we're going to get an answer of, we're going to get here 33, and divide 33 by 2, and we're going to get an answer of what? 16.5. Again, to find our median, what did we do? We did 15 plus 18. I have to make this clear. So let me see. Let's go. So we have a space here. So let's go again. Let's list our numbers. 13, 15, 18, and 30. So these two will be the two middle numbers. So to find a median, we do 15 plus 18 divided by what? 2. This is 18. It's going to give me 33 divided by 2. That will give me 16.5. So that's my median. It says the mean of 5 numbers is 12. And when another number is added, the mean becomes what? 11. So let's take 2 cases here. Let's take the initial case here. In the beginning, how many numbers do we have? N. The mean of 5 numbers. So we have 5 numbers. And the mean for those numbers was what? 12. Later, we added another number to it. So the number of numbers now we have would be what? 6. And the mean for that would be what? 11. So the question here says that find the number that was added. So what we need to do is to find the summation here. Let's apply this formula that x bar is equal to summation of all the x's divided by n. Now x bar is 12. We don't know the summation of all the numbers, but we can find that. We can find the summation of all the x's because n is what? 5. We multiply 5 by 12. The summation of all the x values will be 5 times 12. That will be 60. We do the same thing over here. We say x bar is equal to what? The summation of all the x's here over what? 6. And x bar is 11. So we have summation of all the x's over what? 6. So we have the summation of what? The x's to be what? 60 what? 6. So how do we find the number that was added? We subtract these two. So the number that was added would be basically 66 minus what? 60, and we get what? 6. So the number that was added was what? Basically what? 6. So the ages of 5 students in the class are what? 13, 14, 17, 18, and 19. They want us to find the standard deviation of their ages. So the first thing we need to do in the process of finding the standard deviation, let's find x bar. So to do x bar, we're going to do what? 13 plus 14 plus 17 plus 19. No, 18 and 19. Plus 18 plus 19 divided by 5. Now, when we do this computation here, we're going to see that our x bar will be 16.2. So we got x bar. So what we need to do is to find the deviation for each one. So let's find a deviation. So the deviation for the first one. So we're going to take the first number, which is what? 13 minus our 16.2, we're going to have negative 3.2. Then we do the next one. Again, we do, this time the next number we have is 14 minus the mean is 16.2. We're going to have here negative 2.2. Then we do D, the next number we have is 17 minus what? 16.2. So here we're going to have 0.8, 0.8. The next one we have is going to be 18 minus 16.2. It's going to give me 1.8. And then we do D equals to 19 minus 16.2. It's going to give me 2.8. So we have all our D's. So what we need to do next is to sum up, find D squared and sum it up. So let's go. D squares. So the first D squared over there is negative 3.2. So I'm looking for D squares. So the first D squared is negative 3.2 squared, and that will give me 10.24. The next one is negative 2.2 squared, and that will give me 4.84. The next one is what? 0.8 squared, and that will give me 0.64. So the next one is going to be 1.8 squared, and that will give me 3.24. And the next one is 2.8 squared, and that will give me next one is 2.8 squared, that will give me 7.84. So I will add up all of these D squares. Out of all of these D squares, and I'll move to the next slide, and then I will apply the formula. Let's move there and see how it works. So let's go to that. So the formula we are applying will be S equal to the square root of what? The summations of D squared divided by N. When I did the addition of all the D squares divided by N and got this, my result was what? 5.36. I took the square root of that. My answer is 2.32. So that's the standard deviation for what we are looking for. Okay? That will give us our standard deviation. So actually, if you want, I can even go into details here to say that the summation of the D square was 268. How many numbers did we have there? 5. We divided that by what? 5. I don't think it was 26.8, sorry. Divided that by 5. And then we got 5.36. Took the square root of 5.36, we got 2.312. So that's how we do that. It says the pie chart shows the distribution of 600 mathematics textbooks for science. So here's the pie chart that we're talking about. Degrees. This is for arts. $45. This was for science. Here was 75 degrees, and this was for business. And this was for technical. This is 150 degrees. So what I want us to do several parts of this problem. A, how many textbooks are for the technical class? So let's see. To find the number of textbooks, we need to take the degree of the technical class and divide it by the total degrees in a circle and multiply it by the number of what? Textbooks. 600. So A. So we do for technical, the degree is 150. So 150 as a part of 360 times what? 600 will give us the number of books for the technical class. Now, first of all, they did not give us 150 in this problem, correct? They did not give it to us. So we had to compute 150. What we did was did 45 plus 75 plus 90, subtract that from 360, correct? subtracted that. So now we divide this, and then we're going to see that it's going to give us what? 250 what? So the number of textbooks I went to the technical class was 250. So then in B, what percentage of the total number of textbooks belong to the science class? So to determine the percentage, we find what fraction of the circle is the science class. The fraction is 45 out of the whole circle, which is what? 3 what? 60. We divide this and then multiply by 100 because they wanted the percentage. 1 0 cancel 1 0. And then we're going to have 450 divided by what? 36, and we'll do the computation. We're going to have 12.5%. So 12.5% of these books went to the science class. Correct? That's it. Good. Again, like I said, actually I kind of put the 150, and the problem did not give you 150. So what it gave us was these three. To find this 150, we had to add 90, 75, and 45, and subtract that from 360. So what we did was 360 minus what? 90 plus 75 plus 45. And that's how we got a 150 for the technical class, and we planted it in the problem. Okay, so yeah, this is the mean. These are problems that we've already gone over, so it's not going to be hard. It says the mean of 72, 65, 83, and x is 80. So x bar is equal to 80. What is x? So what I'm going to do is say x bar is equal to the summation of x over n. So it's 80 equals to 72 plus 65 plus 83 plus x over 4 is equal to that. So we combine here, it's going to be 320. If we add these numbers up, we're going to have 220 plus x. Subtract 220 from both sides. X will be equal to what? 100. So that's our answer. 100. X is equal to what? 100. Well, this is how we'll do these problems again. Just a repetition, the circling of the concept. So that's it for this video. Again, thank you very much. This has been a production of Field, the Foundation for Equity and Excellence in Education in Liberia. We are committed to provide quality content, instructional materials across our content area for Liberian students, teachers, and our Liberian community. We hope you can find our product useful, and if you do, please don't forget to make a little contribution. The more you help us, the better we can make our product. Again, thank you. Send us your feedback to fieldliberia2015@gmail.com or the executive director at fieldliberia.org. Again, thank you very much.